So can people in the back hear me? Okay, yeah, so my name is Xiaowei Yang. I'm an assistant professor at UC Irvine. This is joint work with my colleague Jin Sudik and my student Xin Liu. It's academic work, it's an idea, and I flew all the way from sunny California to Toronto just to hear what you think about it. All right, so what motivated this work is that I'm a network user, and I read news and I read NANOG too. So basically it's like over a year ago, there's like a former CEO of SBC made this public announcement. Basically they wanted to take some profit share from internet upstarters like Google. They don't want them to free ride their pipes. So what I'm feared of is that if they really make the internet into two tiers and put the competitor service like Vonage into the slow lane, and make their own service travel through the fast lane, then gradually I'm afraid that they may take down the entire internet one by one. All those services all became supplied by AT&T. This looks very familiar. It's like the singular network, the cell phone network, a closed, vertically integrated service, which we really hate. It's not like I'm paranoid or something. In like about last year, March, there's a slash dotted incident like Comcast. It was accused of voice over IP blocking, and even like Windsurf, they share the same concern. So there are some attempts of enact net neutrality, like regulatory steps. However, it has some drawbacks. The first problem is that it's very difficult to draw the line. I'm sure you all know that there's like two examples, like the proposed bills. Basically, the idea is that we want to rule out quality of service. There should no data prioritization at all, because if you allow data prioritization, then it's possible people may abuse it. So that's the concern. And also, religiously, some people just against regulation. It seems like against the free market policy. So far, we don't know, whether there should be regulation or what kind of regulation would be. So here, after I read all those news and after, I really hate the singular, cell phone networks, what I thought is that, okay, let's take a step back, right? First, we want the internet to be open, and to my opinion is that, that makes the internet really successful, like everyone can run applications, attach something to the internet. So maybe alternative would be that let's just design a clean quality of service interface such that even the network want to prioritize data based on contents or application types, or the non-customer end of data, they cannot do. I mean, so basically the idea is that, if I leave the content clear there, it's really hard to resist the peaking. But if I basically just seal everything out, maybe that just solves the problem. So basically, my goal of the design is that first, I want to allow a differentiated service because it's a legitimate service model. The customer could purchase capacity or traffic profile at different prices, and they can decide how to use the quality, how to use the service, like put different bits in the diff serve code point, saying, hey, for this one is my voice over IP data, I want a faster service. And the other one is like a bulk transfer, background transfer, is okay, whatever you do best effort for me. So I want to allow this kind of service model. But at the same time, I want to entirely prevent network enforced data prioritization based on content. Say, yeah, this is Skype data, I'll charge you more if you don't pay me more. So I want to prevent this type of data prioritization. And another thing is about the non-customer ends of data. So basically what I mean is that the internet is basically paid by both ends. So from user point of view, even there's a duopoly, we still have a choice over, between DSL and the cable modem. But from Google's point of view, once the user has made their own choice, they select either Comcast or SBC, then it's a monopoly to the other end. If they don't pay, they cannot get through the PAP. So basically, I want to prevent data criminalization based on the other ends, not the customer ends. So if the ISP decide that they want to discriminate their own customers based on how much they pay, I think it's perfectly legal. So basically, the key idea is that I will just blur all the packets. So if the ISP, they could tell Vonage from the other applications, then they could do this kind of discrimination and gradually take over the internet. But however, if everything just looks like a bit, then the hypothesis would be that probably they wouldn't want to put all the bits into the slow pipe, because the user can simply do a matter. Okay, I purchased a 1.5 megabit per second DSL service, and now I'm only getting like 10 kilobit per second. So this is not acceptable. So this is the high-level hypothesis. So what is the challenge here? Encryption is pretty easy. We can use encryption to seal all the contents. But there are two remaining challenges. One is that how about discrimination based on the non-customer IP addresses? Google has a lot of data center, but I believe after a while I can figure out which IP belongs to Google. And the other one is like a traffic analysis. Basically, I can say, okay, small packets probably more like Skype packets, and the larger ones probably more TCP packet, even I encrypt all the data. So in this talk, I'm basically talking about approach to prevent discrimination based on the non-customer IP addresses. So for traffic analysis, theoretically, there's no solution. Like we can do the traffic padding, change the intervals, but it's very expensive and inefficient. So in the current design, I haven't incorporated any traffic techniques against traffic analysis. Another problem is that I don't know how real they are. You can tell me, say, in the real world whether it's easy to do traffic analysis at the real time and then do discrimination based on the traffic analysis results. All right. So what is the big picture? So the high-level idea is quite simple. We assume that there are networks like Cogent who made a public announcement that they support net neutrality, would like to protect their customers from being discriminated by other ISPs. So those ISPs, they could offer a service, which I call like a neutralizer service. It's kind of like a genetic net. Then what the traffic looks like is that for a user like N from a discriminatory ISP, when they send data to any customer of Cogent, they actually just put a generic neutralizer's IP address in their packet header. So at the AT&T side of the network, all traffic looks like it will have a source address with N's address, and then a destination address as a neutralizer's any customer address. And the data will be end-to-end encrypted. So what the neutralizer does is that it takes this data. It's actually in the encrypted part of the data, it would have a encrypted destination address. The neutralizer just decrypt the data and get the real destination address and forward the packet to the destination. So this is a high-level picture. The hard part to do is that we want this to be done pretty efficient and robust, as the neutralizer cannot keep state. That's the design requirement. And also, we need to, there's like some step about sharing a key between the N and neutralizer. We don't want the Cogent to keep the per IP or per source IP state about the key. So here, it's just like my trick of doing stateless key setup. So basically, when N, before N start to send data to any customer in the neutralizer domain, it will send a packet with this a short ISA public key. And once the neutralizer get the data, itself maintains a master key. This is like a secret key. And it's used to announce the source IP address and its master key to generate a short session key. So this key will be used by a user N to encrypt the real destination IP address. And the neutralizer used the RSA public key attached in the first key setup message to encrypt the nonce and the secret symmetric key generated from the hash of the source address nonce and KM, and then return this to N. So here I chose use the RSA encryption because it can be done rather efficiently, like using a very short exponentiation. And so this is the key setup step. And note that this key setup step, the neutralizer, if it becomes a performance bottleneck, it can offload this encryption step to any customer. Basically, the neutralizer can just forward the first packet. It generated the nonce and the key, forward the packet to Google, ask Google to do the encryption if itself cannot keep up the speed. And then, like after N receives this packet, for the data packet, it will use this symmetric key, stateless key, to encrypt Google's IP address. That's the real destination address. And then use the end-to-end encryption to encrypt its payload. Once the neutralizer receives this packet, it uses it from the nonce field and its own master key and ANS IP, it will generate the symmetric key and decrypt the data and forward the data to Google. And here in this first data packet, the user can send a key request requesting a new key because the first key set of data is encrypted using a short RSA key. It may not be secure. It's like after a while, like the ISP may crack it. And after this packet reaches Google, Google encrypts this nuance and new key using the end-to-end encryption. The end-to-end encryption can be made pretty strong. And again, after the data reaches the neutralizer does another encapsulation, use the symmetric key to encrypt the Google's IP. So if you see from this graph, all the data on the set between N and the neutralizer, the Google's IP address is not visible. So it's completely sealed from N's ISP. And we have implemented this on using click modular router using Linux. This is a prototype. So here's some performance data. For key setup message, the RSA encryption message, we can do about 25 kilopacket per second using a PC like with AMD Opteron processor at 2.6 gigahertz. And here, this is like the data packet. Data packet basically involves AES encryption. We can do about like 430 kilopackets per second without any optimization. And I think this can be optimized because like the real encryption costs about like 300 nanosecond. And the vanilla IP forwarding is about 600 kilobit per second, so we are a little bit worse than that. So the related work is like the most related one will be like anonymous routing. So our work is different. It's like I think we have a lot simpler assumption. We assume that there's a cooperating ISP, and also the technical contributions that we are doing connectless anonymous routing. We do not keep any state in the network just for robustness and for scalability. So basically, so this talk, I present a technical approach to keep the network neutral. Basically, the idea is that we will allow data prioritization, but we completely seal the contents and the destination and application types so that data prioritization cannot be done based on contents and on those fields. And the key idea is that I want to blur all packets, make bits just bits, and make the network the bit paths. The technical contribution is that we make this neutralizer service efficient and stateless. So that's about my talk, and comments are welcome.
Yeah, and if we could get the next speaker, Nate Cushman, to come up while we're taking some questions. Yes.
Hi, John Christoph with New Star Ultra Services. More of an observation than a question. I found that really interesting. But as you were talking about, even from the beginning, it's sort of, what I read into that was basically, from long ago, we were against NAT and quality of service because the bellheads were taking over and we were trying to restrict stuff, but now we're trying to save the network with NAT and quality of service from them taking over the network. And I love Cogent, they're great, but it was kind of interesting that you used Cogent as an example, so I just want to make that observation.
Thank you. Yes, sir.
Yeah, James Turner from the Metra. Thanks for bringing up the topic of the 800-pound elephant in the room that nobody wants to talk about. One of the issues I think that's interesting, however, is that while there are a lot of technical approaches that could be looked at this, does it not, in the end result, still come down to the question that if, for example, a consumer, end user, wishes to be able to get a higher quality of service, that you need to be able to provide a way to do that. And it strikes me that that is, to some extent, discriminatory in the sense that if I want to pay $5 to download a movie in streaming mode, I can't necessarily do it if my traffic is equal to the people that are trying to get the same movie on a peer-to-peer traffic at the same time. And you have to provide some incentive or means for the actual carriers to be able to partition their traffic that way. Could you give us your thoughts on that?
Yes, that I agree. But basically, for that type of data prioritization, the ISPs can do so by just setting different traffic profiles, right? Like some turbo user allow doing like 40 gigabit per second, or you allow user to set their deep serve bits. I think basically my point would be that if you want to provide differentiated service based on the network level traffic characteristics, like the number of bytes download, the average download throughput or something, we can do so through a very clean quality of service interface without looking into what the contents like users are actually downloading or what applications they are using. I think I totally support differentiated service because that otherwise the network may not have enough resources to support all users. But what I think is unnecessary is that we do so based on whose data ownership or what kind of applications are running. That I think is not necessary.
Thank you very much.